Okay, any ideas how we might use this counter then to provide a timeout function for those people to actually cross the road? Now I'm saying to you that, yeah, we want to be looking at this carry out over here, this carry out. When this carry out occurs, that's what will take us basically out of a given state and into the next state. So that's what we want to try to have a look at in terms of how to use that. We might want to initialize our counter too. That's going to be important, I think. It's good to know where your counter is actually going to start from. So we'll probably be using this clear function to actually initialize our counter. Now look, if I'm in a given state, let's say a condition, clock period, let's say I'm in that clock period here, and I activate the clear line, okay, when does the counter get cleared? Not in that period. It gets cleared in the next clock period or in the next cycle here. Okay, so if I initiate the clear in this clock period, it doesn't actually get cleared until we get the clock edge over here. So that's important too. Okay, so we'll try to capture that as well. So here we go. We'll try to come up then with a state diagram now that's going to reflect these fixes that we've actually made. All right, so let me start over here and we'll see how we do this. So look, let's look at the first state. We're going to say that this is north, south, green, and wait. All right, so let's look at that like so. All right, we're going to look at basically the switch output, if you like, from the SR latch, which is an input to our state machine. So this is coming from the SR latch now. SW, remember, is the Q output of the SR latch, but it's an input to our state machine. If that is 0, then we're going to stay in the same state. No problem with that. We've looked at that before. If it's 1, then we'll move to the next state. And so here we're going to change the lights. We've got north, south, then yellow. We've got our wait condition here. There is wait. Okay, and yes, we set a reset, or we initiated a reset, right? So there is our reset, which resets the SR latch, doesn't it? Okay, when we're in this particular state here. Then we move to the next state. Now, in this next state, what are we doing? We've got north, south, red. We're going to generate the wait signal for the wait light. Okay, so there we are in that particular state. Then we'll move to the next state. In this next state over here, what are we doing? We're letting the people cross the road, so that's north, south, red, and go. All right, so there we are, letting the people cross the road. Now, let's use that counter. So let's look now at the carry out of the counter. Now, if the carry out of the counter is a 0, then we're going to stay in that state, letting the people cross the road. It's only until this carry out becomes a 1 that we'll move back to the beginning again. All right, so we'll reflect that like so, moving back to the beginning again. All right, now let's think about that a second. Okay, so that's good. All right, north, south, red, go. We're going to let the counter count up to what? 1, 1, 1, in other words 15. Okay, so it's 4 1s for the Q outputs. Okay, when the counter's reached 1 1 1 1, carry out becomes a 1, and then on the next system clock edge we move back to this state where north south is green and wait, and we're waiting for people to cross the road again. Okay, now what do we have to worry about here? Where's the counter starting? I don't know where the counter's starting. Okay, because that counter's counting all the time, all right? Because it's the same clock that goes to the counter as goes to your state variable flip-flop. So I don't know where the counter's sitting. So really what I want to do is I want to, as it were, initialize the counter. I want to initialize it at 0. So I could use a clear function to do that. So where should I generate the clear? It was no good generating the clear in this state. Okay, if I generate the clear in this state, then basically the counter then will always have 0, 0, 0, 0 in it. Okay, and the carry out will never occur. And you'll never get out of this state. If I generate the clear signal in the prior to the state in which I'm looking at the carry out, let's look at that. So I'll generate the clear. Remember, it's a LCLR signal. It's a low acting signal. I'll generate it here, okay? So that's when that signal is asserted. When I get the leading edge of clock, I move into this state. The clear signal goes inactive, and the counter starts at 0, 0, 0, 0. Let's go back to that timing diagram again for the counter. So here we are back with the timing diagram. Here we're generating this clear signal, all right? Now this will be in the state prior to what we want to be looking at a carry out, okay? But I'm just trying to initialize that counter so that the output really has a 0 in it. So I asserted the clear. The output of the counter didn't go to 0 until you get the next clock edge over here. There is that output of the counter going to 0. Okay, so I assert the clear in the state prior to where the output of the counter will be zeros. So in other words, back here is where I'm asserting that clear. When I get the clock edge, okay, I move into this state, and also the condition of the counter becomes 0, 0, 0, 0. So how long do I stay in this particular state? Well, it's going to go from 0, 0, 0, 0 all the way to 1, 1, 1, 1. So how many clock periods is that? Pause the tape perhaps at this point if you're not clear. Going from 0, 0, 0, 0. What's the next clock going to be? 0, 0, 0, 1. On the next clock edge, you're going to go to 0, 0, 1, 0, and so on. So I think it's not hard to realize that you're going to be going from 0, 0, 0, 0 to 1, 1, 1, 1. It is 16 clock periods that you'll remain in this state. Okay, so you remain here now with 16 clocks, which is enough time for the people to cross the road. Can you see a problem with this system though? Okay, we've now got enough time for people to cross the road. We've dealt with the switch issue, yes, but is there another problem that we've got here? Now think about that for a second. Okay, well look, let's look at a scenario. Somebody wants to cross the road. In fact, a whole bunch of people may be wanting to cross the road, right? So somebody presses the switch, right? Okay, sets the SR latch. SW is a 1, we move into this state. We reset the SR latch, right? So in this state, we've reset the SR latch. We've moved into this state over here. But now imagine somebody else has come along. What do typically? They press the button again. And so really, SW's gone back to a 1 perhaps because of some other person coming along and pressing the switch. Okay, we're not resetting in this state. I guess you could, but we're not, okay? All right, you move into this state. Yeah, could you reset in this state? Could you reset the SR latch in this state? Sure you could. No problem with that. But you stay in this state, letting the people cross the road. You're in there for 16 clocks. You move back up here. Okay? Supposing you had initiated the reset in that state. Well, that's okay. You've moved back up here. But don't forget, you might have a stream of people trying to cross the road. So what's happened? People are continuing to press the button. You've moved back into this state. What's going on? Well, somebody's pressed the button again. SW's a 1. So you come out of this state. On the next clock, you move into this state. And you start changing the lights again, allowing the people to cross the road. What's the problem, though? Well, if you had a steady stream of people wanting to cross the road, then you've now what? You've got a situation, potentially, where you've only allowed really one state period for the cars to get across. Okay? Which equally is not a good situation. So ideally what you want to do with this system is have maybe a minimum time now to allow the cars really to get across. So in other words, perhaps you also want to use a timeout feature as far as the cars are concerned, because you could have a steady stream of people trying to cross the road. Have a think about that issue. Have a think about that as a problem. You see, it is at this state diagram level, okay, that you really are discussing this design, perhaps discussing this design with a customer. Is it doing what you want it to do? Is that reasonable? Okay, think about that. A better scheme might be the following. So what I'll do now is try to develop another state diagram, maybe to take into account that issue as far as the cars are concerned. So let's try this, okay? So here, let's imagine now, okay, that we have our first state. This is north-south green. This is weight, all right? There you are. Okay, we're looking now at the output of the SR latch, SW. Remember, that's an input to the state machine. It just happens to be an output from the SR latch. Okay, that's 0. Of course, we're going to stay in that state, just as before. That becomes a 1. Then we'll move states, okay? So I'm not changing anything just yet. Now we'll change the lights. North, south, yellow, okay? Weight as far as the people are concerned, yes? This is what we generated reset before, and that's okay. Could generate it other places if we wish as well. So there's our reset, as it were. Okay, then I'm going to move into the next state. What am I doing in the next state? North, south, red. I'm maintaining the weight condition. Yeah, okay. Then in the next state, what did we do in the next state? We moved into that next state, all right? This was where we had north, south, red, and we had the go condition, all right? Yes, that's the go condition for the people. And what were we doing here? Yep, we were looking at the carry out, weren't we? So there, if you like, is that carry out. If the carry out were a 0, well, we're staying in that state. If the carry out was a 1, well, before we went back up here, but we won't do that this time. Remember, we need to actually initialize the counter. We did that in the state prior to looking at the carryout. So this was where we generated that clear, okay? So that when we moved into this state, we knew the counter was sitting with all zeros. All right, but this time we're going to do something else. We're going to move into another state over here. So if the carryouts are 1, okay, we'll move into this state here. And in this state here, what are we going to do? Well, we'll have north, south, red. We'll have the weight condition, okay? And then we'll move into this state here where we actually have north-south green, weight condition, and we'll time out in this state. So we'll look once again at the counter carry output, okay? Which is, of course, an input to our state machine. If the carry out from the counter is 0, we'll stay in that state. If the carry out of the counter becomes 1, then we'll move back to the beginning over here like so. All right? All right, now what do we do here? Remember, we want to initialize that counter. When we move into this state, we want to know the counter is actually starting at 0. So I have to what? Clear the counter in a state prior to. So we'll go ahead and clear it here. So here, LCLR signal being asserted up here. Okay? Now, what does this mean? Does that fix that problem? Yeah, look, here we allowed the people to cross the road. We were in this state for 16 clocks. Then we came out of this state, right? Instead of going back here where you could have had somebody that had pressed the switch again, causing SW to become a 1 and then just immediately go through again, we went here. And basically we had north, south, red and weight, which is a good feature anyway, that we didn't have before. We've cleared the counter out. Then we've moved here, which is north, south, green, and weight. And now we're allowing the cars to cross this junction now, this crossing now. And we're allowing the cars to what? We're in this state for how long? For 16 clocks before we come out and then go over to here. And then we're going to be looking at the switch input. Okay? So this now is a much more workable traffic light system. All right, we're going to take a break at this point. And then when we come back, let's have a look at how we might go from a state diagram to a state table again.